All right, so today we're going to prove that right triangle similarity using angle-angle congruence, and I can use right triangle similarity to solve problems. Okay, so here's the theorem. It's called Theorem 60. I don't even consider it a theorem. It's fine. The altitude to a hypotenuse of a right triangle divides a triangle into two triangles that are similar to the original triangle and to each other. Okay, in other words, if you have your notes, this is where you can cut it out, and it's actually kind of fun. If you take this baby triangle and the big triangle, they're similar by angle-angle because the big triangle has a right angle and the baby triangle has a right angle. And they both share angle A. So by angle-angle, they are similar, right? And then from here, we can take the medium-sized triangle. Okay, and that comes out over here. And you'll notice that it also has a right angle, just like the big triangle. And they share angle B. And because they are similar to the same triangle, they are similar to each other. We can use the same transitive property that we've been using this whole unit and the last unit. It's exciting. Okay, so now we can say that all of these triangles are similar. The hardest part is going to be drawing the triangles so that you can see the similarity. You'll notice that triangle ABC, so this big triangle, is congruent to ACD by angle-angle, and triangle ABC is similar to triangle CBD by angle-angle. And then because they're similar to the same triangle, we can say that they are similar to each other. Okay, so this is where you cut it out. So you have one triangle. You have triangle PQR. That's the big one. Now, if we cut out the small triangle, so that would be P. So, and then I want you to cut it out and glue it right here. You'll notice that Q is in the same spot as Q. So that means that Q for the baby triangle will also be in the middle. S is all of a sudden in the same spot as P used to be. Notice S is in the bottom, P is in the bottom of the middle one. Okay, and then all of a sudden P is in the same spot as R. So the baby triangle, so that is similar to triangle SQP. Okay, and then the medium one, so I like to think about it as I pulled the S out and I dragged it down so it was in the same spot as the right angle on the other one. Okay, we're going to do the same thing to the medium-sized one. We're going to pull S out and put it over here so it's in the same place as the right angle on the big one. Okay, so now we can say that triangle, now if you notice P is in the same place as Q. And S is in the same place P used to be. And R is in the same place R is. So there is my similarity statement between all three. Okay, if you literally think about this as pulling out the right angle and pulling it down off the page, it helps so much with writing this. Okay, I wrote the similarity statement for this one up here. I want you to write the similarity statement for this. Okay, and you need all three triangles in your diagram labeled. I want you to do the same thing here. Once you've done that, we'll come back together right here.